Evening. In the previous video, we discussed decimal decoder and decimal decoder IC, that is 7445. Now we'll discuss, I'll explain the encoders. So encoder means it is opposite of decoder. Opposite of decoder. So this is the general block diagram. Opposite, as I say. So decoder means we say n to 2 to the power n decoder, but here we say 2 to the power n to n. So inputs are more than outputs. So here inputs are 0 to 2 to the power n minus 1, outputs are 0 to n minus 1. So it also provides code conversion. Code conversion. There also it provides code conversion. Decoder here also provides code conversion. One second. Yeah. Also provided for conversion of binary information from one form to another form. It is an inverse of decoder. Encoders are inverse of decoders. So decoders have more inputs than outputs. Decoders have more inputs than outputs are called as encoders. So decoder means less inputs, more outputs. If it is more inputs, less outputs, then we call it as an encoder. So simplest encoder is 2 to the power n to n line decoder. And this is the general block diagram. Okay, logic 1 on one of its 2 to the power n input lines causes binary code to appear at the output line. That means if input 2 is selected, 1, the remaining all 0, the corresponding binary code, if it is a 3-bit, it displays as 0 1 0. If it is 4-bit, it displays as 0 0 1 0. Corresponding binary code will appear at the output lines. So we'll discuss with an example. At most only one input is asserted, that means selected. At any time only one input is selected. In the decoder only one output is selected. In the encoder only one input selected at any time. The remaining are not selected. So again 2 to the power n to n line decoder is the simply collection of OR gates. Collection of OR gates. Yeah, let's see an example. 8 to 3 line decoder. That means 8 inputs and 3 output. So encoder. If you say decoder, 3 to 8 decoder. If it is encoder, it is 8 to 3 encoder. Opposite, inverse of decoder. See the block diagram. So there are 8 inputs, 0 to 7. To the 0 to 7 we connected x0 to x7. So x0 is LSB, x7 is MSB. And output side are 0 to 2. So 0 to 2 they are connected to Z0 to Z2. So here Z0 is LSB and Z2 is MSB. So let's see the corresponding truth table, the function table. Inputs are x0 to x7. Outputs are Z2, Z1, Z0. Okay, Z0 is LSB, Z2 is MSB. We cannot say LSB and MSB in the input side. Either we can write x0, x1, x2 up to x7, or we can write x7 first, then x6, x5, x4, like that. No issues. So observe the first row. Input side only one input selected, that is x0. In the output side, corresponding binary information, the binary code, that is 3 zeros. In the second row, x1 is selected, the remaining are not selected. So output is corresponding binary, that is 0 0 1. Okay, so only one input is selected and output is corresponding binary. Similarly, observe when x4 is selected, output is 1 0 0. So this is what the function table of 8 to 3 line encoder. See the expression. When you write the expression, observe x2 column, z2 column, z2 column. So z2 is 1 when x4 is 1, and when x5 is 1, and when x6 is 1, and when x7 is 1. So the expression for z2 is x4 plus x5 plus x6 plus x7. That means if any one of x4, x5, x7, 6 and 7 is selected, z2 supposed to be 1. Similarly, observe z1 column, z1 is 1 when x2 is selected, or when x3 is selected, or when x6 or x7. That is why z2 expression is x2 plus x3 plus x6 plus x7. Similarly, for z0, z0 is 1 when x1 is selected, or when x3 is selected, or when x5 is selected, or when x6 ends. So we are saying r. So r means summation. So the expression for z0 is x1 plus x3 plus x5 plus x7. So these are that's what I said. Outputs are simply the collection of OR gate. So the corresponding circuit diagram is, so since there are 3 output, so we use 3 OR gates. 3 OR gates. For Z0 OR gate, we connected the input x1, x3, x5, x7, and for Z1 we connected the inputs x2, x3, x6 and 7. Similarly for Z2 OR gate, we connected the inputs x4, x5, x6 and x7. So this is the corresponding circuit diagram for 8 to 3 line encoder. So remember, encoder is an opposite of decoder. So in the decoder we use AND gates or NAND gates. So here we use OR gates for circuit diagram for implementation purpose. One second. Yeah, let's see priority encoders. So in the basic encoder, so we have some problem. So these are the expression for a basic encoder. Just now we observed, right? So in the basic encoder, there is a problem when if 2 or more inputs are simultaneously selected. That means only one input supposed to be selected. Suppose if 2 or more inputs are selected, there will be a problem. What is that problem? Assume, for example, if both x3 and x5 are selected. So we are expecting the output corresponding to either x3 or x5. But it gives output corresponding to x7. Why? Because see, the x3 is included in the expression z0 and z1. So both z0 and z1 is 1 1. And x5 is included in both z2 and z1. Already z1 is 1. So z2 is also 1. So all 3 output becomes 1. When all 3 output becomes 1 means that is corresponding to x7. So here it is selected. If either both x3 and x5 are selected, we are expecting output either x3 or x5, but we are getting the output x7. So this is what the problem. In such a case, we assign a priority either to x3 or x5. Then we will get a proper output. Okay, so that is why priority encoder is developed. Okay, so if both x3 and x5 is selected, we need to assign a priority. So that is why priority encoder is developed. Okay, remember in the basic encoder only one input should be selected. So if 2 are selected, output is not correspondingly either any of the selected inputs. So priority encoder is implemented and in a priority encoder we assign a priority. So priority is assigned to input lines. Whenever more than one input line is asserted at any time, the output is determined by the input line having highest priority. So in the same example, if x3 and x5 is selected, it checks which input is high priority, and it gives output corresponding to the highest priority input line. This is what the priority encoders. Yeah, let's see 3 to on example 3 to 8 line priority encoder. Yeah, this is the function table. 8 to 3 priority encoder. 8 to 3 priority encoder. 8 inputs, x0, x1 up to x7, and outputs z2, z1, z0. And here we included one more output, that is valid. See, observe the first row, all zero. That means no one input is selected, and output is 0, 0. Okay, na? So here valid output means valid output is also 0. That means, see, when all outputs are 0, 0, it tells that x0 is selected. But here x0 is also not selected. That is why output is not valid. So if it is 0, it is not a valid. And observe the second row. x0 is 1, remaining all 0. That means x0 is selected, the remaining all not selected. So the output is 3 zeros. So that is valid. Correct? So valid output is 1. Observe the next row, that is x0 is don't care, x1 is 1, the remaining all 0. Okay. So output is corresponding to x1, that is 0, 0, 1. Right? Now the question is, when x0 is don't care, it can be either 0 or 1. If it is 1, x0 is 1. Correct? So two inputs are selected. The remaining are not selected, and still output is corresponding to x1. So here we say 1 means high priority, 0 means low priority. We can say 1 means high priority, 0 means low priority. In such a case also, in the third row, when x0 is 1, here it is don't care, if it is 1, so x0 and x1 are high priority, remaining are low priority. Here two inputs are high priority, no? x0 and x1 both are high priority, no? So among this default priority, it checks default priority. Default priority goes to high priority goes to I subscript decimal value. So here x0 and x1 subscript values are 0 and 1. So 1 will be the high priority. So that is why we say x0 is don't care. If it is 1 or a 0, by default it goes to x1. Similarly, observe next row. x0 is don't care, x1 is don't care. It can be either low or high. If x2 is high, output is corresponding to x2, that is 0, 1, 0. Similarly, observe the last row. From x0 to x6 is don't care. Either it can be 0 or 1. If x7 is 1, code is corresponding to x7, that is 111. So here valid input distinguishes from the all output is not selected and from the x0 is selected. So from the table, as I said, the same thing. When x4 to x7 is 0, that is low priority, and x3 is 1, that is high priority, it gives the output corresponding to x3, that is 011, regardless of the values of x0, x1, x2, x3. If all are again high priority, default priority goes to x3. So valid output distinguishes the situation that no input is asserted, that is first row, and from the x0 is selected, that is second row. Since both 0 0, both 0 triple zeros, so 0 means it is invalid, 1 means it is valid, that corresponding to x0. So this is about priority encoders. So in the next video we'll discuss construction of cascading of priority encoders.